And I just want to show one quick example inside of Rhino, bringing some of this work back into the Rhino environment and taking a look at where we can find use from these types of workflows. Back inside Rhino, I have an earlier geometry example from one of our Grasshopper exercises. And I'm going to start with this, and we're going to work through texture mapping inside of Rhino, prepping this model to unwrap with its textures preserved, and also augmenting those textures after we've done it. So after the unwrapping has already been performed, and actually maybe we'll try both prior to and after it's been unwrapped to show how these kind of Colab notebook image processing steps could impact our texture mapping. So, it might be obvious, but we could just take screenshots as we were kind of working with in the examples and take views of a 3D model. But another way to convert this into 2D information that we can work with these image-based methods on is by unwrapping it and directly operating on the texture. So to do that, we first need to get a texture on this object. If we switch to our Arctic mode, we now have our object with no material. If we select this object, go to Properties, and then the kind of tube of toothpaste or paint tube is really what it is, we see that we have a Use Layer Material property set. So it's going to default to that layer material. We can also select our default material, which is what it's already set to actually. And we now have this object with that default material set. If we want to apply an image to this, it's as simple as just dragging and dropping an image from our hard drive onto this object. As soon as we drag and drop it, we have it mapped on, but we have it with a particular type of texture mapping. So it defaults to a particular type of texture mapping. In Rhino, if we want to change the texture mapping to get the image projected in a particular way, we need to go to this kind of coiled or wrapped texture mapping panel, which is right next to that tube of paint. This texture mapping panel has options for apply surface mapping, apply planar mapping, box mapping, spherical mapping, cylindrical mapping. These are all different ways that we can take an image and project it onto a 3D geometry to get a texturing applied. So you can imagine that we have to distort that image in some way to tell it to map on. Right now what's happening is we're mapping based on surface mapping to each one of these surfaces, and they each have a totally different mapping because they're each individual surfaces. If we wanted to start combining this, we could just click apply box mapping. We could just hit enter and apply a bounding box with our box mapping, and it's going to already apply. We can see that there's some strange kind of overlaps translating the image aspect ratio to this particular object. If we want to edit this, we can click show mapping, and this gives us a mapping widget which we can actually scale. So we're scaling this kind of bounding box, and we're now able to move this texture in each axis based on the bounding box projection. You can see though it's having quite the issue by trying to map a bounding box texture or an image via a bounding box onto such a complex geometry. A more continuous way to map this would maybe be to use a spherical projection and then a bounding box so that we have the continuity of the sphere. Again, we could go to show mapping, and we can now adjust the position so that the mapping is less distorted at certain points. And then there will be some points of distortion. You can see as we move that sphere away from the surface, we get more distortion on many parts of the surface. So we move it back or scale it up, and we can also rotate it around. Maybe scale it down, move it through. So we're just working on aligning this particular texture with our geometry. So once we get that texture mapped how we want, we just want to explode all of these surfaces. So we can explode each one of these surfaces, join them based on which surfaces we think can unroll without overlap, without exploding as well. And then we can select all of these, run remove, so underscore remove flipped normals. So we've run that and it's preserved the texture still. So if we now select our grouping of surfaces and then type bake, we can bake that texture to its own texture map. And then we just want to go into materials and make sure that that's its own material. If it somehow was saved over or saved similarly to some other one, we would maybe see like a duplicate or a copy listed here, or we would have some notice saying that it's the same material as somewhere else. So now we can take that one particular group, type unroll surf, use explode no, labels no, and keep properties yes. Hit enter. And now if we take a look at this unrolled surface, we can now move this freely. And each one of these surfaces, even if we have to explode it because there is too much overlap, if we take a look at this, it is now mapped just like our three-dimensional surface. So we can see that these striations have now been unwrapped across the flattened version of that surface, and where we have this kind of texture following the geometry at the base, we still have that following the geometry edge at the base. So this is the unwrapped version of those textures. So now if we were going to make a paper model with this, what we could do is use these as a template for the surfaces. We could plot this on photosatin paper at a large scale. We could then spray mount that onto a thicker board like a 2-ply museum board. You could then cut that either via laser cutter or by hand, cut those, glue the edges, and then re-establish or reconstruct the three-dimensional geometry. So we can go ahead and just start with that one, or maybe we'll do two actually. So let's do this one as well. So we'll do two of these groups. So I'll now take this group and we are going to bake this texture at full resolution. And we can see it has its own texture map, which is great. And now if we unroll surface, explode no, labels no, keep properties yes. And then just move this away from our first group. We should be able to now explode and see that this is actually using that bake textured map. So those two are okay, they don't overlap. These ones don't overlap, so we can keep those. And we would want to get this as tightly packed as possible. So this is what we should be seeing here, this top portion, which we are seeing across these. So we are seeing those show up on our unwrapped group. So we now have texture A, texture B, and then we would have a C and a D in this particular geometry as well. Now here's where it gets, I think, fairly exciting. We can take these textures and use those in our notebooks. So I'm going to jump back to the Colab notebook. I'm now connected to our OpenCV methods notebook. We could use any one of these methods, but I'm going to start with a canny edge method. What I want to do is upload our texture file and then use this advanced canny edge detection to find the edges and then override the texture applied to our object in Rhino in 3D with this updated image, the canny edge image. I can do that by selecting our image and dragging it into the upload folder. So we'll do text A, and then we can do text B. Once those have uploaded, we can select the three dots, copy path, and paste that path as an input into our canny edge detection. Now we can hit play, refresh, and check our edge detection. So that's the edges on the first one. We can now update this input file path to text B, and we can also say rename this and make this A so that we keep that in mind that that's A. Run this again, refresh. We now have a second one, and we can name this B. We can then download both of these files And we can use both of those files to overwrite the texture inside of Rhino. So all we have to do this is just drag and drop these new canny edge texture. So if we drag our B image onto our B set of surfaces, we see that right now there's a subtle disconnect, a slight disconnect between our canny edges and what our texture was. And that's because we've actually rotated that in our notebook. So if we come back here, we can see that we've rotated this around. In this particular script, we've also resized it. Well, we don't want to resize it. So I'm going to just comment out all of our resizing options. Now if we hit play again, refresh, we get it right side up and also at the resolution that we want. So I'll delete these two former files, and this is going to be renamed to B, and then we need to do A as well. And now we can just download both of these, and when we drag and drop in Rhino, we should see them mapping properly. So if we drag our B on, we now see that alignment happening, and then we can drag our A on as well, and we can see this update. So those are our canny edges relative to that texture, and we can also see that update on our 3D model. So we actually get our canny edges drawn out in 3D onto our surfaces. Now, we can do this not just with canny edges, we can also do this with any of those operations. So if we scroll down to something like the segmentation, we could input these original images in our segmentation, copy path, paste in the segmentation. We want to make sure that we're not rotating and that we're not resizing, so I'm going to comment all of that out. And now we've made our segmentation map, which we can check. So this is our segmentation map based on those textures. So it looks like each one of our surfaces has a few patches on it. So we'll call this one A, and then we can download this file and upload it to Rhino. So if we just drag and drop that in Rhino, we now see those segmentation patches on our 3D geometry. So we're getting nice clean segmentations relative to actually kind of the curvature here, but it's actually related to the texture image for this particular mesh. We can do the same thing with the B by just changing this value and running it again. Now we get a new segmentation map, which we can rename B, and then upload this to Rhino as well. And then click drag and drop, and we now have that segmentation on those surfaces. So the segmentation maps in particular might not look like much, but what we can do with them is use them as masks to either post-process in Photoshop kind of texture compositing, or we could also use them as inputs to machine learning algorithms and apply a certain type of thing to red or a certain type of thing to blue or purple or green. And we can have these kind of patches represented in the output of these machine learning algorithms. Or we could have them present in the output of just a manual kind of Photoshop collage that we develop a surface texture on these geometries with. So we can use any OpenCV method or any image generation method in the same way. So even if we just manually drew something on these surfaces based on their unwrapped texture maps or baked texture maps, we would be able to update their textures inside of Rhino. This is going to allow us to make paper models by unrolling the surfaces with baked textures, and we'll be able to wrap the 3D paper model with the actual texture that we've applied to it. We can also then connect any image generation methods using any generative AI model with our model building in the physical world. That's all for this introduction to Colab notebooks, Python outside of Rhino, and image processing using computer vision, as well as where we wrapped up with texture mapping inside of Rhino and reapplying those processed images in Rhino. In the next video, we're going to get into generative AI using ComfyUI, a browser-based interface for machine learning.